we will be talking about measures of shape. Previously we used a data set, so we'll try to use the similar data set and we'll try to see how we can measure shapes using the frequency distribution table, and then how we can draw some graphs. So the data set we had before, let's say I'm going to use them. Let's say I have the height data of some tree. Let's say this is my sample, and then in my sample I have 27 sample size, and I would like to create a table, a frequency distribution table, so that the data set we have right now, it's in a raw format. That means we would have another kind of data set where we will transform this using these values, and then we will create some group data. So you can see within this group how many observations we have. Within this group, how many observations we have. This is what we call a group data. But whenever we have it in a raw form, that means just the values we observed, this is called raw data set. Okay. So let's say we have a data set, depending on how large it is. Let's say we have few hundred values, and then it will be easier rather showing the everything in the data set. If we create a group, that will be easier for us. So you can see we actually have a data set from a class where we have information of students' weights, and then we created groups, and we said that in each of those groups how many observations, that means how many students were there. Okay, so this is what we call the frequency, and we add the symbol F, the class frequency. Also, how much, what was the width of this class, that's what we call class width. How we would know how many classes will be there? So you can see we have 3, 4, 5, 6, 7, 8 groups, and then each of those groups we have some widths. Width is 2. So how we would know how many classes will be there? That means groups. Also, what would be the width? There are some rules that we can follow so that we can create this frequency table. And then at first you need to follow these steps so that we can find what would be the class, how many classes will be there. You can use this formula. And then this is not mandatory that you have to do that, but in this course we are going to follow these steps. And then you also need to find the range and then determine what would be the width. So let me show you using my data set. So you can see I have the height information I showed you before. Then I have sample size 27. Then I use that formula. So you can see I use the 1 plus 3.33 and then use the log values of the sample size. Then I found my class. It's really larger decimal values we have. So I try to say that let's round up, and then I round it up. Sometimes people round down depending on what's the lowest and highest values. You can see the number of classes I'm going to use is 6. That means there will be 6 groups in here. I added just sample values just to show you some examples. And then what's the range? It would be better if you sort the values from smallest to largest. So you can see smallest is 153.1, 184 in centimeter. So, or maybe in meter. Meter would be too much, but centimeter, you can think about that. Then in centimeter, height of those trees, or maybe in feet, you can say that. So the range would be smallest minus largest value. The class width, so you can see I divided the number of classes by the divided the range by number of classes. Then I found what would be the class width. Then you can, if you find really long decimal values, you can think about what might be the range and what might be the class width, because sometimes what happens is that if we use way too short class width, then you will see that it's not adding all the values. So for the first lower class limit, we try to see what's the smallest value. So if 153.1, I try to go a little bit lower, and then we use the same decimal. So you can see I added 152.5. Try to use the same decimal. If you have, let's say, 153.12, then you should use the same decimal numbers. So I use 152.5 and then 152.5 plus the class width so that I can get the upper class limit. Similarly, in other class limit, you can find the same so that you can see if you have the smaller one, then you can add the class width. The lower class boundary, so we go one more decimals so that there is no overlap in our values whenever we try to find the frequency. So you can see I added the 152.5, the lower class limit, minus 0.05, because we would like to go one more decimal point. If we had, let's say, 152.67, then what we would do is that 152, I need to use two decimals. So let's say I have 152.67. Then I should use this value minus 0.005 so that I can go one more decimal. That's the way we are trying to do. Since we have only one decimal in our data set, we are going to use 0.05 subtraction. Same thing, we have to add 0.05 so that we can go one more decimal. You will see that in our table, the frequencies say within this limit or within this limit, how many values are there. You can find, I found one, and then within this range, how many values are there, I try to find. And then for the class mark is actually the mid value. That means you can take average of class limits or average of boundaries, then you will find the same values. Okay. So that's what they explained in here. Same thing in the textbook, we explained them. So you can see that since we have in the data set no decimal value, so we did not use any decimal value in the class interval, but whenever it's actually goes to the class boundary, we added 0.5 decimal, the precision. So the mid value is 58, and then how many values are within this interval. Then relative frequency would be, if you find all the frequencies, then sum of all the frequency, it will be 200. So if you take the 200 and then take the percentage of 8, let's say 8 is, if we 8 is out of 200, and then within out of 100 it will be 4. Same thing for cumulative frequency, you can see that you have to add them. That means the first cumulative frequency would be the frequency we have, second one would be adding these two, third one will be adding these three, and then at the end you will get how many total frequencies you had over here. Yeah. Similarly, you can find the relative frequency in percentage. That means the percentage of these cumulative frequency you found, and the inverse will be just the because it will start from what you had, the everything together, then you have to subtract them, subtract the values. You have, let's say, 200 and then subtract 8, and then you got 192, and that way you can subtract the values and get the inverse cumulative frequency. And similarly, you can find the relative inverse cumulative frequency. So all we need to do is that after finding this frequency distribution table, then we would like to present them in graphs. So in the textbook, you will see that we actually created different graphs. So let's say we have the qualitative information. So qualitative information, we can say crown class, maybe we have 4 crown class, and each crown class, what are the frequencies? That means how many trees we have in each frequency. And we can create either bar graph, or rather using the boxes, you can use just a line. Whenever we talk about the histogram, then you have to use only the x-axis. Always remember that. Write down what you write on the x-axis and y-axis, and what's their unit. So you can see the class boundaries we used in here. 7.55. You will see that in the table in your textbook, the table we have. Let's show you. Nope. Okay. So the class boundaries we have in this table, or you will see that the class boundaries 7.55 and 9.85. So we usually use the upper the class boundaries 7.55, 9.85. All these. Let's go. Okay. So you can see we use those class boundaries, and we try to see in each of those groups how many frequencies we found. Then we create the histogram. And then similarly, you can find pie chart. We're not asking you to create pie chart because you have to divide just by how many in each of those categories. That's qualitative information. But in this graph, you can see we try to find frequency polygon. By the name of it, you can you have to use the DBH dataset, and then DBH is your variable frequency polygon. That means you have to use the frequency, and then that means the frequencies we found in our dataset, we can add them. And then class midpoint, that's the most important part. Previously we used the class boundaries, but we have to use class midpoints for frequency polygon. If it is cumulative frequency, again we have to use class boundaries. Same thing for inverse cumulative, we have to use class boundaries. And then you can see other examples in here. So in the measure of central location and variation from frequency distribution, it's similar to how we calculated mean and variance and standard deviation. Only difference is that this time we are going to use the frequency as well. So in the frequency table, we have to use the frequency values and then class mark. Class mark is defined by MI, and then frequency is FI. So each of these two values, you have to multiply them, and then sum with the multiplying the 61 by 10, and then plus 64 multiplied by 32 plus 67 multiplied by 58. So after that, you have to divide them by total number of frequencies. Then you will get the group mean, or the average, or the central location mean for the group data, or for the frequency distribution table. Similarly, we can see the equation is same. Like previously we did not use the frequency, we just used the value. In here we have to use the mid value, that means the class mark squared multiplied by the associated frequency, and then sum them. Then you can see previously what we had, the values, maybe store them, maybe use that value squared divided by how much value you got in total frequency. Similarly, we last time sample size -1, but this time we have to use total number of frequency -1. That way you can find the group mean, group sample variance, and if you take the square root, then you will find the standard deviation for the group data. Okay, that's it for the lesson 1. I hope you enjoyed, and then try to practice the examples and exercises we have in the textbook. Thank you.